Okay, second part of polar coordinates. Graphing equations using points. So they give me a function like, or an equation like r equals 2 cosine of theta. And they want me to graph it out. How I'm going to graph that out is I'm going to make a table of data. Because I don't know what my radius is. It's not like just one point. It's going to be a whole bunch of points and I'm going to put it together. So I'm going to say this is my theta, this is my radius once I do my theta, and the radius equals 2 times the cosine of theta. So thetas that I know with cosine are going to be 0 pi, pi over 3, pi over 6. Oh, I did those backwards. Pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and then 2 pi, which obviously this one's going to be the same as this one because they're the same location. So I'm going to go cosine of 0. The cosine of 0 is 1 times 2 is 2. I'm going to go cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2 times 2 is the square root of 3. Cosine of pi over 3 is 1/2 times 2 is 1. Cosine of pi over 2 is 0 times 2 is still 0. Cosine of 2 pi over 3 is cosine of 2 pi over 3 is negative 1/2 times 2 is negative 1. Cosine of 5 pi over 6 is negative square root of 3 over 2 times 2 is the negative square root of 3. Cosine of pi is negative 1 times 2 is negative 2. Cosine of 7 pi over 6 is negative square root of 3 over 2 times 2, negative square root of 3. Cosine of 4 pi over 3 is negative 1/2 times 2 is negative 1. Cosine of 3 pi over 2 is 0 times 2 is 0. Cosine of 5 pi over 3 is 1/2 times 2 is 1. Cosine of 11 pi over 6 is square root of 3 over 2 times 2 is the square root of 3. And then cosine of 2 pi, which is just a repeat of 0, is going to be 1 times 2 is 2. So now I'm going to be able to do this on my polar graph. So I have a radius of 2 and a degree of 0, or not a degree, a radian of 0. So I'm going to be right there. Then I'm going to have a radius of the square root of 3, 1 point something, 1.4 maybe, and pi over 6. So pi over 6 is right here, 1.4 is maybe right there. Pi over 3 is here, and 1 for the radius is here. Pi over 2 is here, and 0 for the radius is here. 2 pi over 3 is here, and a radius of negative 1, which means it reflects across the axis. So it goes over here. Remember, when we have a negative radius, we reflect across. Radius of negative square root of 3 and 5 pi over 6. So 5 pi over 6 is here, reflected across is over here, and then it's going to be right about there. Negative 2, which means I'm on the second, and I'm at pi, reflected across is going to be right here. So now after that, it's just going to keep repeating what I already drew. So I'm going to go like this and connect those guys. So that's how we would graph those guys out. Not exact, but pretty resourceful, or pretty useful. Okay. Now we have different lines of symmetry on polar graphs. We have symmetry on the polar axis, which this is the polar axis. And so the symmetry means that this piece right here is reflected across this piece right here. So they're the same, which means that I have symmetry across this axis. So if I folded it together, they would be together. We know that's true when theta equals negative theta. And we'll have an equation to use to check it out. I can also reflect across the pole, which remember the pole is right here. So that means that I have something that maybe looks like this, and this piece is reflected across, so it's also over here. And we know that happens because r is equal to negative r. And then, so this is reflected across the polar axis, this is reflected across the pole, and then we can be reflected across theta equals pi over 2. Pi over 2 is right here. So what would happen there is this piece would be reflected right here to be this piece. So that's what we're looking at. And we know that happens because both r and theta are equal to negative r and negative theta. So I have to check it out. So let's say that they give me something like an equation that says r equals 1 minus the cosine of theta. So I'm going to check, does theta equal negative theta? So if I plug in negative theta here, remember we had an identity that said the cosine of theta, the cosine of negative theta equals the cosine of theta. We had that rule. So that means that by my identity, this is true. So that means that this does reflect across the polar axis. To check the pole, I'm going to go negative r equals 1 minus the cosine of theta. I'm trying to get it to say r equals 1 minus the cosine of theta. So I'm going to divide by negative 1. And these are not the same. So that means it does not reflect across the pole. And then for theta equals pi over 2, I would go negative r equals 1 minus the cosine of negative theta. This, by my identity, can just be cosine of theta. And then I multiply by negative 1. And that's not the same. So it doesn't reflect across theta equals pi over 2. Then I would use that same table that I just did, same kind of table to find points and to graph it out. Where did that go? Right here. Same kind of table.